So like when you're doing, you'll see it's also in the syllabus. It's last name, I think underscore first name, underscore exam one, and then underscore, and then question number, based on the question numbers that are listed right here. Because when it's all said and done, I am going to come in here and like for labs that have submissions or tests, I can just click download submissions and I'll get them all downloaded at once. And so I'm not like, and then I can just immediately upload them or open them with Visual Studios and check your stuff, and I'll have your name right on it. It's easy to track. If everyone just submits exam one, question one, I get exam one, question one, copy 1 of 20, copy 2 of 20. Yeah, that's gonna suck. So have your name on it. Otherwise, I'm gonna, like, if I have to go figure out whose yours is, you're gonna lose a point. Other than that, like, just errors, like doing it, like not following instructions. The instructions are fairly clear, but there's a lot of leeway. Wow, people code their own way, so there's a lot of leeway in it. So, let's see, we got something in chat. Hi, Isaiah. I have gone through, and for every assignment that's been uploaded, if someone had a question, I've responded. I also have gone through lab 1B through 1E and looked at all of them already and said, oh, looks good, or given feedback. I'll go through the rest as time permitting. I'm going to try to get it all done before Wednesday. But like a lot of them, most of them were just submitted. Like if you're not worried about it, you've run it and you know it runs. Don't worry about it. Like but if you have a particular question that you want answered before Wednesday and you don't have it as like part of your submission, like in the comment box on the side, email me about it. Say, please check this lab or so and so. That way I can get you feedback before you start taking your test. All right. So we are, what module are we on? We're in the test module. You can see what's coming. There is a practice. When you do it in here, wow, Dill shows up. The fuck? I didn't even know he's still enrolled. Yeah. I know I see you online every once in a while. When you're in here, you won't need laptops or anything like that. Just writing utensil for on Wednesday. Because like the lab portion's at home. I'm not going to try to make you code it in a very short period of time. So there's just a written thing to do in here, and you don't need your computers. We're going to do this review today. The rest after here are questions that you'll see on the test. You can try to look at them now, but you won't be able to see them until Wednesday night at 6. If I click on them, it's going to show you ahead of time what the questions are, and I don't want to do that. So the question, all you do looks like text box. I would code it in whatever IDE you're using and upload the file with that name. If you do type it up in the text box, you have any errors, you're fucked. Like you should do, and just upload the CPP file. Examples of things to upload, you can see right here. Yeah, let's see who's done this. David has. Okay, so, and I can't see his full naming file. Let's see. Let's just. There we go. It's a CPP file. That's not what I wanted to do. They're CPP files. If you upload the SLN file as a solution file, it requires having the whole fucking folder, and you're not sending the whole folder, so I won't be able to do shit with the solution folder or the solution file. Definitely the CPP file. When you're looking for, I'll show you how to find it in a second when we're going over this one right here, the in-class test 1 review. I have already put it over here, and we're gonna go through it. Oh, the in paper portion, I'm gonna be here at 3:30, by 3:30. And I'll be here till 6:30. Whenever you want to come in that time frame to do it, you can come in and do it. If you want to come early and do the test early, you can. If you want to come late, but I'm leaving at fucking 6:30. If you ain't done at 6:30, you're fucked. I'll just say that now. I'll be here by 3:30. I might be here beforehand, depending on traffic and stuff. But and then at 6 o'clock on Wednesday, the labs will actually show up, and you have till Sunday at 11:59 p.m. So you've got some time. They're not long. All right, here's our review that we're going to do. It's going to cover a little bit of everything. We have the class where this is the doubly linked list one. This is, we've got the items, next, pointer, previous. We're not going to, oh wait, I do have the R linked list here. We have our linked list here. This is our forward one only. This is the singly linked list. That's David's. What am I fucking looking at? It's not what I wanted. What is that? That's not it either. I thought I had it. There we go. It says in class review. I knew we had fucking some note on it. We got a note on here. We're going to look at point. We're going to look at circle. Point is like Cartesian coordinates, X, Y. This is one of the few ones. Some students in here like to use this command. Like instead of saying return X, some students are doing this X. It's handy only really if you're calling something else that's going to have an X. Because we have our X and Y are private. So the only way to access these is by either being in our point already and you already know it's yours, or if you're calling another point, that point will have a name and you would do name.x, whatever it is, or something like that. So this is really only handy when there's doing like using this is if you're doing something where you had, like we're going to go with void, double distance calculator, and we'll take in another point. God damn it, parentheses. Point arg. And if you want to do a distance formula, let me include power real quick. If you wanted to have a distance formula, we could do power. It includes CMath. So POW does the format for it. I think I put the wrong cursor there. POW goes, the thing being square rooted, this is the ret, or not square rooted, the thing, the base, and then exponent. So what is it? POW? We would do like, for calculating the distance between 2 points, it's square root of x squared, or brackets, x minus x2 minus x1 squared plus y2 minus y1 squared. And so if I were doing this within a point, like this is within the point method, I need to take in another point. And so what I would want to have, I'll do a quick thing that says double base to put in there. And I would want to put like this x minus arg x. And that needs a POW. Comma 2. I don't think I need that thing. I think I just need POW. Plus POW. This y minus arg y, comma 2. That's giving me the base. And then I could go base 2. Or base square root would be 0.5. This is where this becomes handy, because I'm calling another point and it has its own xy. And so like if I just say x minus x, they're like, what the fuck? Even if I go x minus arg x, the x here, the first x could be confused for either one. So by having this in there, we're going to go over this later on, but some students are already using it. And like some of them are like excessively used, like it's a little too much. So like, this is where this is really helpful. Like this is helpful here. It tells me it belongs in this one, this point that we're referencing. It would be very much like me up here sitting here saying, I am drinking this tea, rather than saying I'm drinking tea. Like, well, no shit, you're drinking that tea. It's the only tea around you. So some students are doing this on everything, and it's excessive. It looks like you're not sure what this is for. But we're gonna do this again at the end of the semester. So I'll just comment this shit out. That's not really where I wanted to go. But some students are already using it, I want to talk about it. So the point function has an xy and it's got a print. And it's got a virtual void. It does not need to be, we don't have the equal 0. So anything that inherits from this doesn't have to use it, but it can. We've set it up with a template, so it could be an integer, it could be a double, whatever we want it to be. Doesn't even need to be Cartesian coordinates. We could have like, it could literally be used like name and ID at this point. Like a name and an ID number, because if I put in string, it would work. Circle, though, is inheriting off of it, and so it's definitely going to use numbers. And circle has a radius. We've seen this in other stuff we've worked on, and it builds on point. So the point it's using is the center. There's only 2 things that really define this circle. It's all points that, well, the sentence definition of a circle is all points that are equally distant from a central point. So that's what it is. The central point or the center is our point. Then we've got a radius. It does use, it has the virtual void print. It's doing, there's 2 ways to do this. I did circle with center point, and we have, if we want to call the point without calling the print function, like the point has a print function, it's down here. But if we want to call point that we're using, you're going to want to scope it and say what you're doing. And I don't know that you've seen that before. Or we could just as easily say, see out circle with center point. Center, we'll do this. And then do point t dot print. And that would do it as well, because that point t dot print is going to come up here and call the print function, which shows the point. There's a couple ways to do that. But inheritance, remember, so that if this has an equal 0 on virtual methods, if it has equal 0, it must be implemented in derived or children classes. If not, it's optional. That's just a refresher. And virtual is what allows it to be reused later on. If you, anytime you need me to slow down, say something.
I need some time.
What? Okay, I'll stop. That's what it sounded like. Ice was clinking right near my ears at the time.
Okay, I'm good now. Thank you.
Anybody else need longer? All right. This shows templating with the inheritance. We've done it before, but good to see again. We have our node class. This is one that's set up to be implemented as a doubly linked list if we want. If you want to templatize this, I didn't use T again because we got T up above. I thought OBJ is for object. I wanted to make it a little clear, like anything can get put in this motherfucker. We don't just have to put numbers or strings or characters. Like we can put students in nodes. We can put whatever we want in nodes. So by calling an object, I thought it would make it like a little bit clearer. And so if you want to templatize the node like that, just make sure you put it throughout it, including on the constructor. For mine here, notice that I don't have this set up with prototype up above and implementation down below. I wanted everything like nice in one spot. On your test, you should have prototype and implementation down below for the practice. But I wanted everything in one spot so you could see it a little bit easier. Yeah.
In template class T.
Yeah.
So this class circle public point T. Does that mean we only have access to the public points of point T?
No. Well, yeah.
Yeah. So
It means you have access to the public parts of point T.
So you have to make sure you get inside functions there.
Yes.
Make sure. Otherwise, it won't work.
And we do.
Okay.
So recall structures or structs default to public. Classes default to private. And so like if you don't want to worry about set and get methods, you can go with the structure, but realize that anybody that's accessing your code can easily tamper with it, change values really easily. Otherwise, with using a class, they're protected. You have to use accessor methods to access them. Yeah. Okay. So our node, we're doing objects. We've got our accessor methods. We've got set and get previous, set and get next, and set and get item. And we've got a print node list. And this is just specifically for doubles. Maybe I should put that in the name. Let's do a control find on that. Control F. Do find and replace print node list doubles. Yeah, I think I only use it once. Because since we've templatized it so anything can go in it, making a generic, because this is like a regular C++ function, to make it so that I can put any node in it, like, and do a print. If I throw in like student, fucking doing get item, if it's going to require a print function. I might be able to templatize this. I didn't try it. Let's check it out in a second. Oh, this is something I want to see. Talk about using function returns in CS rather than CS and function returns. Okay. Some students are doing stuff where I think Max was one of them. I think I mentioned to Max. If it's designed to return a number, don't do C outs in it. Do C outs in the main where like C out reference the function, the return of the function. I get the desire to throw it in the function, but let's put it in this way in terms of you're playing a game. There's a bunch of fucking monsters. They all have hit points, and every time you hit them, it's going in, it's pulling in the function and going, did this monster die? So it's going to check, are its hit points 0? Has it dropped to 0 health? If so, return a yes, like this will be a Boolean, and return a yes, it's dead. But if we put our C out in there, and you run around and you're fucking playing Gears of War or whatever, and you're fucking shooting everything, and every time you fucking bullet hits them, it says not dead yet, not dead yet, not dead yet. It's dead. That's the equivalent of throwing a C out in something that doesn't need the C out. That would get really obnoxious really quick, right? So keep the C outs on something that, like, functions that have a void return is a great spot for C outs. Our print functions tend to have a void return. The only one that should really have C outs in it that doesn't have a void return is your main. And you could make this a void main void just as easily. Okay. So notice we have just nodes here. We don't have a linked list class. Okay. You have your hand up as a question, or you just throwing gang signs?
Oh, sorry.
What are you doing?
Close it still.
Okay. So we're going to show polymorphism with linked up nodes. So I made a node. You made it a point double. We're doing a pointer, its head. And it's really fun trying to set these up where you're sending in an object that's been templatized to a node. Getting this is like, that seems like a lot, right? You got to have the double parentheses because the node require, not parentheses, but the arrow brackets, because the node requires the arrow brackets. Point requires arrow brackets because it's templatized. Getting it right can be fun. Then I've gone through and I've set the point value. And since we don't have a linked list method, we should go through and make sure previous and next are set to null pointers. Does that make sense what I've done on line 106 to 111? We just set up our head node, our head point, and it's point 3.3, 5.5. Then on 113, I said, let's make a copy of that. CURR is for current. This is going to be where our current, like what we're working on, is going to be. So if we want to make a linked list out of this by hand or hard code it, whatever one we're working on is here, but we don't want to lose head. We always need the start of the chain. So we're going to leave head alone. So I made a copy of it with current. And I said, we're going to set up the next node for current. This sets up node 2. This sets the item in node 2. And I can't jump to the next node until I've given it a way to do the previous thing, because we're doing previous and next. So this sets up that backwards chain right now. Right now I have a pointer to where I'm at, the current node, and I can always do a pointer to the next one by doing get next. So this connects the next pointer back to the current. So finally, we can jump to the next node, which is node 2. And it doesn't matter where I set the next pointer to be null pointer, but if I do it before I jump to the next node, I got to do this get next thing. So that's why I jumped first. I jumped to this node before doing this null pointer for shorter code, really. It made the line a little bit shorter. And I've got print node list double head. Notice that the polymorphism isn't working for our nodes. So we'll see that when I click print in a second. Because notice the second item is a circle. We set this up as a point, but by setting up the head node to be a point, it's going to try to treat everything as a point. It's going to ignore this circle's print function. Because it's not like a full linked list. This is one hard-coded in the main. So it's showing my 2 points here, but the second one should be a circle. So it should say circle with center so-and-so and radius of so-and-so, a radius of 7.8. I can see right there. It's not doing it. So it's because we're doing it in the main and it's stuck to being this. Node is an object, and by making the linked list here, we haven't set an overall polymorphism thing, overall thing that with inheritance where it works well. We do have things that do work well with inheritance though. For example, vectors. So if you want to do the inheritance stuff, you probably want to do a vector. So I did the vector here. I did point double my list. And so my vector is called my list. It takes in points, but this one will show inheritance. I put in 2 points with circles, 2 points and then 2 circles. And when I do the run, it looks like it's going backwards. My list dot back and print. So it's printing the last circle first and it's deleting as it goes. This while loop is deleting it while it goes. But now it's actually doing the polymorphism. Because the overall vector here, the vector was set up as a point thing. And so everything in it is a point thing. And the point can, the inheritors, the circles can build since they inherit off of it trigger. The normal nodes don't work like that. The nodes is just a regular class object. Now there is another thing that does work like this. Our linked list, the linked list that we've been doing, we have a very, like the beginnings, the generic version, the non-completely filled out version of the true STD library list, which is list. Okay, we're going to talk about this more in chapter 6, but this is like a segue. So you can see, like, we're not going to make you keep doing the linked list stuff we did, but you need to know how to do it and how it works so that like you understand what the fuck's going on. If you don't know how a linked list works, you're just like, this is magic and you're going to be a shitty programmer. But as long as you know it's a chain and you're jumping along the chain, you go back and forth and what it's going on, then you're better off. But we can do it here, doing the same thing. Now this is like our linked list, but it's got the full STD library and all the stuff they've done to make it go with it. So our list that we hard coded didn't do shit. This is a list. It's a short list. It's 2 items. But when we do it here, it works fine. Does the same thing. Notice the while loop is back and then print, the delete, the pop back. When we're putting stuff in, it's pushback. Looks and acts just like a vector, except it's a list. So you've got that ability to move back and forth along it, and it doesn't have the array structure that like vectors have. We'll talk about that more. That's where we're going to be going in chapter 6. But this covered a couple things. It walks you through how polymorphism works. Is one of your lab assignments for the test is doing polymorphism. So make sure you know how to do this. It's good with vectors. If you templatize it, the structure setup that you're going to need. Then the other part of your lab is going to be hard coding a linked list. It's going to be I think it's going to have a hard coded linked list. It's relatively short there's three labs. One is the polymorphism. The other two are related to each other. Do one, and then question one is like fairly short. Question two builds on question one. But they have you doing this linked list stuff by hand. This is the templatized version. If you don't, I don't recall if I have templatized set up in it. I don't think I do. But I try to make my reviews related to the test. So that's what's going on. Those are the kind of things you can expect to see in the labs. Notice we were able to do pretty much like show all of it. 3 labs worth in like 150 lines. The longest one might be question 3 with the polymorphism, just because I like have you set up. You'll see by the name. You're making polymorphism with D&D characters. So I'm going to have you make a base character, and then I'm going to have you make several different classes with just like an ability in it. Yeah.
Is memory management gonna be emphasized for them?
You should have it. And we have it here. Our vector and our list do the delete. Anything that had a new needs a delete. I don't know that I did it up here. On my shit up here. Wait, where do we go? Right here. No, I didn't. So let's do delete current. And delete head. If we want to make it real good, we're going to set head to null pointer first. And we'll set current to null pointer first as well. That way that shit's really gone. We went through that quicker than I thought. That's all I had set up for a review for today. Do you guys have any questions? Yeah. Eli.
So I was messing around with I think it was 3 a few days ago, and I found out something interesting, and I wanted to see I wanted to understand more on how it works. So let's say you're doing like a del mid function, right? Like a delete mid, whatever, and then like you're trying to delete some like a specific target within an array. You can, what I did first was that I had it start with if the head is equal to the target, then do this. If the tail, first cycle through the entire list. If the head's the target, then do this. If the tail the target, do this. But there's another feature where you can, it seems like you can almost unlink a specific part of the linked list. So you can go forward, right before you reach the target, you stop, you link to the one after the target, and then you do the exact same thing backward, where you link the one after the target to the one before the target, and it completely gets rid of that target, and then you can delete it immediately.
Isn't that what delete mid would do?
Yeah, but I mean, like,
I'm confused. How's that different than what we were doing?
You can get that done within like 2 pieces of code, 2 lines of code. That's what I meant. Like, I did not know that it was like. I'll show you right now. I'll show you what I mean. Because I didn't like.
Let me pull up our lab that we like. It's been a little bit. So let's see. That might have it. Oh, I hope so. It's 425 lines of code. We were a busy group that day, weren't we? Delete mid. Where is that's print? Print. Delete. No, that was our delete mid. Yeah, we had it down to 2 lines of code.
I'll show you what.
If you like your 2 lines of code better than the 2 lines of code I did, as long as they work, I'm cool. This dealt with tail, this dealt with head. Right?
Yeah.
That's all you, yeah, you gotta, wherever the one you want to delete, you jump forward and you say, I want the previous one to be the one 2 cars back. And then you go back to the one you want to delete, and you go back one, and you say the one I want next is to be the one 2 cars forward. And then you can literally just take that thing out. It's no longer there. It's almost like, because I don't have my camera set up. We got a box here, we got our box here, and we got our box here, and they're pointing back and forth. And they're pointing back and forth. And the one we want to delete, let's change colors. Is this, we're going to delete this. So we go to this one and we say, I want this one's previous to be the one 2 cars back or 2 nodes back. And then we go back one, we get previous, and we're going to say, we want the one 2 nodes forward to be our next. And by doing that, this deletes that one. The top red deletes that one, and the bottom red deletes that one. So now this one, the one that we're going to delete, still points to him. But as soon as we stop looking at it, there's no way to access this motherfucker. It's floating free. And that's where we add in the delete node. We set the value here to nothing, and then we delete it. So this goes away. It's not floating around in memory. And that bad boy's gone. Fucking whiteboard did this a little bit better than the fucking overhead, like my camera. Because it's easier to erase and it's harder to do good writing and quickly and stuff. But it worked pictorially. So those 2 and then the deletes. Which is what we have here. I did them the other order. I did go back one and set next. And then I did jump forward and set back. Any other questions? Alex?
On practice exam PDF you uploaded,
Yeah.
the recursive, when you said you want us to trace do the recursive trace, I'm having a hard time working out. I go through that one. It's like I was watching the class we had on recursion, where we did high recursively, and that one I was getting, but this one's like it's all one line, so they're confusing. So
Okay.
for increases or something.
This might be easier with the camera. Let me set it up real quick. I got all sorts of shit up here. This is a multi-purpose fucking bag. You don't even know. I'm pretty sure. I've got paper clips. I've got toothpaste. I'm pretty sure there's a little mini sewing thing, just like a needle and a little bit of black thread. Fucking little cheap headphones in case I really need it. Yeah, this is like a fucking my wife's purse, but in a backpack. Really, I just don't carry my wallet in. All right, projector. And which way's up? Okay. We will set the resolution so it looks good. I'll rotate the camera so the pins are pointing in the direction I'm writing. And so let me write down the function real quick. And then we've got and this is where it gets all clustery fuckery. X equals X plus func K plus func N minus K. And we got our return X. So that's our function. And we're going to do func4. So we're setting up our recursive return. Func4, when I put it in, I've got X equals 1. I'm passing in N equals 4. The if line is a no. So we go to the for loop. 1 is less than 4. We got K equals 1. We're doing K less than N. So we need to do K equals 1, K equals 2, K equals 3. We got to do each of these. We'll do the K equals 1 first, because that's what's going to happen. K equals 1, we do X equals, which is 1. Nope, that's our X. This is the one right here, the pre-existing X, plus func K, which is 1, plus func, make that box a little bit bigger. N minus K is 4 minus 1 is 3. This is going to have a lot of shit going on it. So maybe I should make that box a little bit bigger. All right, so the code stops and starts doing this shit. It can't proceed until it knows what func1 and func3 are. So func1 is over here. X equals 1, N equals 1. If sentence is a yes, it's a go. Return X. So return 1. So this one's going to shut down and it's going to return a 1 right back here. Then we've got func3. I'll let you know this is way more complicated than the one on the actual exam. This one was to make you like do some hard practice. The if sentence is a no here. So we start off with K equals 1. The only ones we're going to have are 1 and 2 here. We're doing X equals 1 plus func1 plus func 3 minus 1 is 2. So the code pauses. Add more colors. That red, that'll work. And black. There we go. We can do some colors here. So at this point, it goes, okay, func1. It does a new one. It doesn't do the one I'm pointing to, but to save paper, I'm doing that. And it goes, oh, that's a 1. We're going to return a 1. It comes back in here and says, boom, 1. And then it goes, okay, func2. Let's do func2. X equals 1, N equals 2. The if statement is a no at this point. So it triggers, the only one it can do is k equals 1, because it's k less than n. And as soon as we go k up to 2, it stops going. So the only scenario we can do is the k equals 1 case. And this, so we got x equals the current x, which is 1, plus func 1, that's func k, plus func n minus k, which is 2 minus 1, which is another func 1. Okay? Both of these come over here and say, oh, that's a 1. They create their own box. It goes to different, more memory goes on the stack. And these both return a 1. This is a 1. This is a 1. So we see that x equals 3 right here. And the next line in the code is, we don't have a k equals 2. So the next line is return x. Return x is return 3. So this takes the 3 and comes back up to where func2 is. Func2 was a 3.
This multiply the function.
Is it 1 time?
Yeah, it's times. Yeah.
Oh, you're right. It is multiplied there. Thank you.
it's gonna be-
Yeah, it's gonna be 2. So that's a 2. 1 plus 1 times 1. Return 2. Excellent. All right, so now we've got 1. So right now, at this line here, we got x equals 1 plus 1 times 2. So 1 plus 2 is x equals 3. Then it does the k equals 2 case. K equals 2, n equals 3. So x equals our current x. Our current x is 3 plus func 2. That's our current k. Plus func n minus k. 3 minus 2 is func 1. Well, these are going to do that again. This one's going down to here and goes, oh, because this was our func 2 box, right? That's our func 2 box. This was our func 3 box. It goes func 2 is a 2. And it says func 1 brings back a 1. And so this says x equals 3 plus 2 times 1. X equals 5. This one's done. And it returns 5. So finally, we're back up here to the 5. These are shut down. Now everything's shut down except this one right now. We are at x equals 1 plus 1 times 5. So x equals 6 currently. At the x equals 6 stage, now we're doing k equals 2. And for k equals 2, we need to do x equals our current x, which is 6, plus func of our current k, which is 2, plus func of our current, or n minus k, which is 4 minus 2, which is 2. I'm not going to draw the arrows again, but they're going to do like, the func 2 is returning 2 on each of these, right? And that's a multiply. So 6 plus 4 is 10. K iterates, we're at x equals 10. K iterates up to k equals 3. Our final one. X equals 1 or 10 plus func 3 plus func 4 minus 3 is 1. It goes down and grabs func 3. Func 3 returned 3. Func 1 returned 1. That's a multiply. So x equals 10 plus 3 is 13. That seems wrong because I'm pretty sure I got 15.
I got 15.
So I missed something in here on some of the algebra somewhere. But is it relevant? You see, kind of see how the recursive trace works.
Yeah.
The one on the actual test is much simpler than this. Because I saw that we're like, this was doing like the Fibonacci sequence one. Fibonacci has you doing, you need the 2 previous numbers. So doing a recursion with Fibonacci requires having 2 other Fibonacci numbers. And it gets tedious. The recursive one on the actual exam does not have a double recursion within each step. It's just a single one. So you should be able to make a box, make a box, make a box, and it's a chain. Okay. What's the other one I did on here? Oh yeah, all hell Hefe.
That one's not too bad.
That's not too bad.
That one looks like that one's kind of fun.
Right. So like what the review we just did on the computer shows you how to hard code it up, but that was doing doubly. Singly is much easier. What?
It's similar to the single English we were doing.
Yeah, yeah,
Right?
yeah.
Okay.
And what Juan has put up. So why this is in here, this is a fun story. When I was working at NASA, I was taking another like person there to work. And he had 3 daughters, like ages like 3, 5, and like 9 or some shit like that. And we take him to daycare and then go to work and pick him up. And I wasn't charging him gas or anything because we lived right next to each other while we were working there. And I know he got them to do this because this is not something that they would have come up with on their own. But they started chanting on the way home. All hail Hefe. We worship Hefe. All hail Hefe. We worship. I fucking recorded it because I was like, this is fire. I was jamming to this. I loved this. And he's like, girls, be quiet, be quiet. No, keep going. Hey, girls, you guys want to get some ice cream on the way home? We stopped. I bought him ice cream on the way home. It's great. I'm like, can I get him ice cream? He said, yeah. Like, because it was like right before dinner, but it's like, and then I don't have the recording anymore. It's like on an old phone. And it's fucking gone. I'm so sad. And they're all grown up. Right? From the same guy. He was in a wheelchair, so like one of the automated ones. He could stand up for a little while. So when we take him, he'd stand up, he'd disassemble his wheelchair, we'd put it in the trunk. So this was like a process taking him to work each day. And at one point, he just started calling me Hef because I was in charge. And to me, I was like, that sounds like fucking heifer. Because I didn't speak Spanish, so no, I didn't know his boss. And I'm like, what the fuck, dude? Why are you calling me a cow? He's like, no, dude, it's boss. And he fucking do a little giggle, a smirk. So I didn't believe him. Didn't look it up. I don't know why. Fucking, it's not like Google was not a thing. I could totally look it up, but I didn't until I was like not working at NASA anymore. And I was telling somebody else about the Hefe story and about the girls chanting this. And I finally looked it up and I'm like, oh, I don't like that name. That's way better than Professor Jones. If you fucking Google Professor Jones, good luck. Good luck finding me. You look for Professor Hefe, my YouTube channel pops up and you can get the videos you want. And I use it for accessibility for my students.
It's like an inside joke too.
Yeah. I wonder if, I haven't talked to him since I've started using it. Cause he works for the NSA now, so he's all like, hush, hush, top secret. I know, pretty sure he does, cause they called me for, like a interview for him, like a background check. That's the word. Any other questions? I'm done. So you're free to hang out with Juan or go or do whatever you want. I'll be in here at 3:30 on Wednesday. If you want to start early, you can.
Can I take a picture of the?
Yep. I will scan this, but if anyone wants to take a picture of this, I'll put it right here, right now. And I will see you guys on Wednesday.
Oh, can you do? Yeah, I do. I'll take a picture. So one of our pages looks best.
Right? You know what? We can start doing that in the future, right? Keep scanning of it. I can always go over here and just set it here for you, those of you that want to take a picture right away. And remember, if you want me to look at a particular thing of code, let me know. Email me. Hop on Discord, say, Hefe, check this out. I need feedback.
Thank you, Professor.
Yeah. You too. F?
Yeah. It's just great shape.
What's your question?
Because I was trying to do this this morning, I was not figure it out, but it looks a lot like what we just did today with the review. It looks a lot like it.
It is. I would probably use a for loop
Yeah.
and iter like,
Oh, okay, yeah.
I would probably make what I would do to make this quicker, because like typing out 50 lines is fucking long. Or 50 circles is long. I would make a short array or vector of like 3 or 4 colors. Then you could literally use for the radius, like whatever increment on you're on for the for loop. You could do that for the points as well. For, I equals 1, x equals 1, y equals 1, r equals 1. Then you do I equals 2, x equals 2, y equals 2, r equals 2. Pick a random color from the color array, and then just do that in the for loop, and you can probably do it all in like 12 lines of code in the main.
Yeah, I was also gonna ask if I had to like hard code all 50 of them, because I did that. What's the next step? I don't know.
It's, if you did it by hand without a for loop, that's really great practice. You probably did copy paste at some point, but I know I would. There's no way in hell I'd type it up.
Okay, if I don't have. Yeah, exactly. So how 50 objects, I'm not gonna do.
Do note, like you will have one on the, we were just looking at it. This is hard code up a list.
What are you talking about with by get next node? Because get next node
What?
is an attribute of a certain node. So if you set it to like no nodes at all.
If you wanted to make a vector with all hail hefe as 3 different strings, you could. And then just have it pull from the array.
Yeah, this one's
As
actually
long
very
as it does it where it's not using a list or linked list class.
Oh,
Just using what we have here, go from there.
okay. But then just remember to like put that void at the very end, or that no pointer at the end. Or not. You know which one, okay?